Hello, mathletes. We are going to be looking at reviewing some of the concepts learned about expressions and equations, and we're going to be doing that whiteboard style today. So, first we're going to look at expressions in terms of simplifying them and then evaluating them. We'll use some expressions that have variables and some that do not. But we'll just look at a variety of different ways we can start with an expression and simplify it. So let's begin here with this expression. All right, so there are a lot of things going on here. We are going to remember that it is our job to follow the GEMDAS rule. So this would be for any groupings. That could be parentheses, that could be brackets, that could be a fraction line, all different kinds of things, absolute value. Then we'll move on to exponents, and then any multiplying and dividing we see from left to right, and then any adding and subtracting we see from left to right. These do not have to be in this order. They can be in either order, but we are going to catch them as we go from left to right. All right, so let's take a look. So we would handle our grouping first. Our grouping is here in this expression. And within that grouping, we're going to follow order of operations again. So no groupings within the grouping, but we do have an exponent here. So 2 times 2 is 4. We'll bring this all down. Keep things nice and neat here. And again, that is still a grouping. I'm going to turn that into a 1. And now we can move on and catch any other exponents because we have all our groupings taken care of. Here's an exponent. That is 2 times 2 times 2. That's 8. And now this is multiplication. This would be addition. This is multiplication. So I'm going to do that, and I'm going to skip over this because this is division. 8 divided by 4 is 2. And now I can go ahead and catch any adding or subtracting from left to right. 8 and 3 is 11 plus 2, and that gives me 13 as my final answer. So this expression, simplified all the way as far as we can go, turns into a 13. All right, let's try one with variables now. So let's take a look at a different type of an expression. And you can see here. All right, so we have terms here. We have terms with x's, terms with y's, and we have numbers, of course. So let's take a look here at what we can do in terms of following order of operations. I would go to my groupings first, but there is nothing I can do here. These are 2 different terms. They cannot be combined. So in that case, I am going to be left to distribute and handle this multiplying. So I'm going to bring down these terms. I'm not handling those yet. I have a positive 3 times a positive 2x. That's a positive 6x. A positive 3 times a positive 3 is a positive 9. And then I have this minus 8 at the end here. And now I'm ready to move on. So I'm going to find any x's I have at this point so I can combine them. I have a positive 4x. I have a positive 6x. And that's it. So that's 10 positive x's. I'm just going to be organized about this. I only have this y. It's a positive 5y. And again, those signs belong to these terms. And then I have a 9 minus an 8, which would give me a positive 1. And that's it. That's as far as we can go to simplify that expression. 10x plus 5y plus 1. So this expression simplifies into this expression here, and that's that. Okay, so the other thing that we do with expressions is we do what's called to evaluate them. So we start with an expression, maybe something like this. And then we're giving some information about the values of x, y, and z. So it'd be this when x equals 2, y equals 6, and z equals, say, -4. Okay, and what that's telling us to do is to place those values in for the variables. So anywhere there's an x, we're going to put within parentheses a 2. And it's important that we have parentheses each time. That's just good algebra. It'll help you to make the right decisions in terms of operations. Always plug into parentheses. So pro tip. Anywhere there's a y, I'm going to create parentheses and I'm going to plug in that 6. And anywhere there's a z, I'm going to create parentheses and plug in that -4. All right, so now I have 3 little multiplication problems to begin with. -3 times 2 is a -6. And then I have 4 times 6 is 24. And then I have a -6 times a -4. We know a negative times a negative is a positive, and that is going to be a positive 24. And we see what's about to happen here. I have 2 positive 24s. That's going to be 48. And then I'm subtracting the 6. So that is 42. And I could have gone in order to do that as well. I could have started here, and that's 18, and then 18 and 24 would be 42. Either way works. But this, when evaluated for these values, is 42. And we still work down like this. This doesn't create an equal sign for us. We're still working down in this way and arriving at an answer here for this type of work when we evaluate. All right, so our next job is to look at equations. So equations, of course, have an equal sign, and we do solve them. We get an answer where a variable is equal to a value that we can plug in and we can use. So let's take a look at solving. So we have these simple 2-step equations. Done lots of these over time. All right, something like this. We want to make sure when we work that we're being good algebra students and we're keeping all of our equal signs in a line, in a straight line, as we go ahead and solve. So we do reverse order of operations here. So what we're going to do first is take care of our adding and subtracting. What we need to do is we need to get this variable on this side of the equation by itself in a whole positive form, and we want to get everything else isolated. Get everything else away from it so it is isolated on one side of the equation. So in order to do that, we have some moves we have to do. So we want to rid ourselves of this 8. So 2x plus 8, if I want it just to be 2x, then I need it to be 2x plus 0. So the only way to turn an 8 into a 0 is to subtract 8 from it. And we know now that this is our balance here. Anything we do to this side of the equation, we have to also do to this side of the equation. And 8 minus 8 turns into a big 0, and poof, it goes away. 2x plus 0 is just 2x. And on this side, I have a -8 and a -2 being added together, and that's -10. And then, again, we don't have that single x that's positive and whole on one side yet. it's being multiplied by a 2. So I think about the inverse operation there. How do I turn a 2 into a 1? So it's 1x. I have to divide it by a 2. So 2 over 2, anything over itself turns into a 1. 1 times x is just x. And here we have a negative 10 over a positive 2. A negative divided by a positive is going to be a negative. So that turns into negative 5. And then pro tip, sigmas plug their answers in and check their work. And we'll do that, again, parentheses, where we're going to plug in. So anywhere there's an x, I'm going to put that negative 5 in there as the value. And I'm going to see if these two sides come to the same number. So 2 times negative 5 is negative 10. Negative 10 plus 8 is negative 2. Does negative 2 equal negative 2? Every time. All right, so there's a simple two-step equation. And of course, these equations can get a little more complicated. We're going to do a couple more levels of equations here. So sometimes there is a little more to an equation, not just the 2 steps, but a little more than that. So let's look at one of these. All right, so you can see there's an x here. We're going to get x equal to something, and x needs to be on one side of the equation in a full positive form, isolated one side of the equation, so we have to work to that end. So first, though, we have to do the work on this side. We will treat each side of the equation like it's an expression, simplify it as far as we can, and then we will start the work of solving. So we always simplify first, and then we solve. Now sometimes there's no simplifying to do, we go right to the solving. But in this case, this needs to be simplified. So let's start that work. So again, I cannot do anything within the parenthesis here. These are 2 different terms. It's apples and oranges. They cannot be added together. So my job then becomes to distribute here. I'm going to bring that negative 3 down. I have a positive times a positive. That will be positive 8x. I have a positive times a positive again. That will be positive 6. And that is equal to 24. And now I'm going to combine like terms. So I have nothing to add to my x's. These are my only x's. But I do have a positive 6 and a negative 3. And I know a positive 6 and a negative 3 is going to give me 3. Okay. And then still working to get that x isolated. So I want to turn this into a 0. So same number, opposite operation. I'm adding both sides. That turns into a 0. 8x comes down. This turns into a 21. Didn't do the best job with keeping that in a row there. I should probably do that again. All right, 8x. Let's try that one more time. There we go. Much better. And my final move is to turn this 8 into a 1. I'm going to use the same number, which is an 8, but I'm going to use the opposite operation. I'm multiplying that x by an 8. I'm going to divide by an 8, and you see what happens here. 8 over 8, any number over itself turns into a 1. 1 times x is just x. And we can leave this just as is. As I've said many times, once we get into working in pre-algebra and algebra, we may leave numbers like this in improper fractions. We want to make sure that we simplify them, but we don't have to turn them into mixed fractions or mixed numerals. However you learned it. It's fine to leave them this way unless we're told otherwise. There are some times where we want to change them, but generally speaking, once we get to this level, it's just fine to leave them this way. So there's a third type of a problem we would want to do, and that is where we have the added element of having variables on both sides of our equation. So let's take a look at something like that. All right, so we see we have x's on both sides. We are going to have to move things around from side to side to get all those x's on one side of our equation so that we can start isolating that x. So we will begin by looking at both sides as if they're expressions to see if there's anything we can do to simplify, and then we will go about the business of getting our x's all on one side and everything else on the other, and then we will solve. So let's look here. This is as simple as it gets. These terms can't be combined. They're different, like apples and oranges. Over here, these cannot be combined, but we can distribute this, -3. So let's do that. -3 times 3x is -9x. A -3 times a -4 is a +12. Let's keep that equal sign and a line, and then we'll bring this down. Nothing to do here at this point. All right, now I'm in a position where both sides are simplified. There's nothing more I can do. So now I want to start moving things so that I have all my x's on one side. So I like to have a positive x, so I'm going to end up moving these. I'm going to add these and add these here. So I'm going to take that 6 and get it to the other side. So I'm going to turn this 6 into a 0 by subtracting it from both sides. So 6 minus 6 is 0. 15 plus 0, 15x plus 0 is just 15x. Here I have 12 minus 6 is 6. And then I'm going to bring down that 9x there. Okay, so now I need to get all my x's on one side. So I'm going to turn this -9x into a 0 by adding a +9x to it. And of course, I'm going to do that to both sides. So this turns into 0. The 6 comes down. And now I have 15 plus 9x, which is going to give me 24x. And now I have one more job to do, which is to get x by itself, one whole positive x by itself over here, which means I have to turn that 24 into a 1. And the way to do that is to divide by a 24. 24 over 24 is 1. I'm going to move over here, which leaves me just 1x. And 6 over 24 is fine. I'm fine having a fraction. I don't want to turn it into a decimal if I'm not told to, but I do want to reduce it. So 6 goes into 6 once, 6 goes into 24 4 times, and there I have my answer. And again, if you want to really be thorough, you would plug this in and make sure that this side, when you plug it in, is equal to this side. You should get the same number on both sides if your answer is correct. All right, so now we're going to go to check and correct. In this video, there are only check and corrects. We don't have an on your own. So there are 3 different check and corrects here. I would suggest you go one slide at a time and then check it over, and then do the next slide, check it over, do the next slide, check it over. So let's begin here. So go ahead and stop the video, and we'll see you in a moment to check your work. Okay, welcome back. We're going to start with this problem, and let's make sure we're checking your work as you go, line by line, and making any corrections you need to make. So as we scan here, we see we're not dealing with variables, just numbers, and we're going to start in our grouping because we know that we are doing GEMDAS, right? So groupings, exponents, multiplication, division in either order, left to right, adding and subtracting either order, left to right. Okay, let's get that out of there and give ourselves some room. All right, so 3 to the third power is not 9. We know that. 3 to the third power means multiply 3 by itself 3 times. So 3 times 3 is 9 times 3 is 27. And I'm going to bring everything else down because that is just good math. All right, so now we have a grouping here, and because these are like terms, we can do that math. That is 3. Again, bringing everything down here. Okay, so this is multiplication now. There's some debate about that, whether that's still a grouping because of the way it's structured, but we'll treat that as multiplication. So we're going to go scan now for any multiplication or division. So this one comes up first. So 14 divided by 7 is 2. And then 2 times 3 is 6. So 12 minus 2 is 10. Plus 6 is 16. So this simplified is 16. All right, let's look at the other one now. In this one, we're talking about terms that have variables, so we're looking for like terms here. These all have signs that belong to them. Think about that in that way. So we have A's. I have A's here, I have A's here, and I have A's here. I have 2, 5, and negative 7 A's, so that gives me negative 2 A's. I'm going to strike those out because I've used them. I have negative 4B here and a positive 2B, which is a negative 2B. So my final answer here is negative 2A minus 2B. Simple as that. All right, and hopefully you got both of those correct. If you did not, please check that work over and correct it and make sure it is right. We're going to go to the next page now. So this is a page where we're going to be evaluating, plugging in values, and then simplifying from there. So again, let's stop that video, do the work, and then check back for a check and correct. See you soon. All right, welcome back. Let's see how we did here. So we have 2, that's an A. We have 4, that's a B, and then we have minus 12. And this tells me that anywhere there's an A, I should plug in a negative 2, so that belongs here. And anywhere there's a B, I should plug in a 6, and that belongs here. Now I'm just going to follow order of operations. I don't have any groupings, but I do have some multiplication to do here. Negative 2 times positive 2 is negative 4. This is 24. This is 12. 24 minus 4 is 20. And 20 minus 12 is 8. So this expression, when A is a negative 2 and B is a 6, becomes 8. We have another one here. So let's first go about the business of plugging in. All right. Actually, I'm going to change this just a wee bit to make this a little easier to, there we go. Okay. So in this case, we have an X here, and we have an X here. So there's 2 places. X is a 2, so I'm going to plug that 2 in here, and I'm going to plug it in next to the 3 here. Then we have a Y here, and Y is a 7. Plug that 7 in, and then we have a Z here, and that Z is a negative 5. Plug that in there. Then we can go ahead and start our work. So we're going to get inside here. We're going to do this as a grouping. We're going to do this multiplication first, of course. So 3 times 2 is 6, plus 7 more is 13. I'm going to bring everything else down. All right, and now we just have a lot of multiplication and then adding and subtracting to do. Negative 4 times 2 is negative 8. 2 times 13 is 26. And we have two negatives in a row here. That's a negative 1 being applied to a negative. So two negatives in a row like that always turn out to be a positive. And that becomes a positive 5. So here we have 26 and a negative 8 is 18 plus 5, and this becomes 23. All right, here's our last set of check and corrects. You have two problems here to do, so go ahead and stop that video, work these through, start the video again, and we'll see how we did. See you in a moment. All right, let's solve these equations. Let me write this out a little larger. Okay, this is a simple two-step equation here. Nothing to do on either side because both sides are in their simplest form. So we can just start figuring out how to isolate that variable. And what I need to do is poof, make this positive 6 go away. And I'm going to do that with the same number, opposite operation, both sides, turning this into a 0. Positive 6 and negative 6 turns into a 0. Negative 3x plus 0 is just negative 3x. And on this side I have a negative 27. And my next move is to, again, isolate that variable. I need that to be a positive whole x by itself on one side of the equation. So how do I get rid of this negative 3 here that's multiplying x? I use that same number, opposite operation, dividing. Once I put any number, positive or negative, over itself, divided by itself, it turns into a 1. Anything over itself turns into a 1. I'm going to divide both sides by that negative 3 to keep that balance in my equation. That means that x is equal to negative 27 divided by negative 3, and negative divided by negative is always going to be a positive, and that's positive 9. So let's plug that in just to be sure. There were a lot of negatives and positives, and we want to make sure we have it right. So anywhere there's an x, I'm going to place a 9 in there and do my work. So this is negative 27 plus 6 equals negative 21. Negative 27 plus 6 is negative 21. And does negative 21 equal negative 21? Yep, every time. All right, hopefully you got that right. And hopefully you took that extra step to plug it in to make sure that your work was correct. Now we're going to tackle this one last problem here. I'm going to rewrite this a little larger. We have variables on both sides of our equation this time, so we'll be looking at that. We also have this side simplified, but this side isn't quite simplified yet. We do need to distribute. So let's do that. 10x plus 5 equals 6x plus 21. And again, I like to have a positive x, so I am going to move these this way, which means I should move my number this way. So I'm going to turn this magically into a 0 by subtracting 5. Do it to both sides to keep my equation balanced. 5 minus 5, poof, goes away, it's a 0. Leaves me 10x on this side. I have 6x, and then I have 21 minus 5 is going to give me a positive 16. Now I need to get my x's on one side, so I'm going to get them out of here and over here by subtracting 6x, turning this into a 0, doing that on both sides. Poof, that goes away. 0 plus 16 is just 16. I'm going to move this up here to continue. And then on this side we have 10x minus 6x, which is going to give us 4x. We're getting there. Okay, so I have all my x's on one side, but that x isn't by itself yet. It's being multiplied by a 4. We need it to be multiplied by a 1. It has to be a positive 1x, a positive whole 1x on one side. So my move here, of course, is to divide both sides by a 4. I'll put that 4 over a 4, which makes it turn into a 1. 1x is just x, and 16 divided by 4 is 4. All right, so pro tip, sigmas always plug their answers in. Let's try to plug our answer in then. So anywhere there's an x, we're going to put that 4 in. Oops, let's see, I want to do it this other way. Hold, please. There we go. So I'm going to place that 4. That's where I'm plugging in. Plus 1 equals 6. Again, anywhere there's an x, I'm putting that 4 in. That was my answer. Making sure that these two sides are equal to one another. I have 8 plus 1 is 9. And 9 times 5 is 45. Over here, I have 24. 24 plus 21 equals 45. And that's correct. All right, well, thank you very much for watching. Hopefully this helped to solidify some of your core skills with expressions and equations. And as always, peace, love, and pie to all. All right, have a good evening.